All right, so I did one with one other outside layer. So this bar and the one on the back are duplicates essentially, to try and stiffen it up. So it's still some play in the knots, I think. It's pretty strong that way. I realized that on the top we're going to have to put a spring, fairly strong spring, approximately here, or on the top or the bottom. And the reason for that spring is so that we have to literally force it down, as opposed to having it just kind of, how do you say, the amount of force necessary to get this thing to lift is extremely too high on the bottom here. But if I have a spring, either like here or on the top, kind of forcing it open, then I have an enormous amount of strength being able to close, but not lift. So I can compress the spring down, and the spring actually kind of allows me to come up. So I think the key here is to have a spring just enough to kind of get us, open the first 10-15%. And then from there, we're good. And it should be strong enough to lift the entire lift and the load on top. I was also thinking we can probably put some springs here to kind of also want to have this open as well, to kind of give us a little bit of assist in carrying the load. A torsion spring here, which we can kind of hide right into the design in a couple of these joints. Anyway, okay, so it's taken a little bit of playing around with to kind of find the optimal configuration. I like this thing, though. When you realize that you can kind of back this out, here, let me show you what I do. All right, so if I unscrew this, this is kind of a tedious process to do mass production with, and we might be able to find something a little more convenient, or use of an electric screwdriver wouldn't hurt none. Anyway, all right, so if I unscrew this, to a certain point, so what happens is I've got a screw here and here, so this holds this tight, and then two screws here, and they hold tight on this. They can't fall out, because when I assemble this, I push the one into this hole, and then this thing literally kind of naturally wants to be at around the right distance. You want them to all be approximately around the same turn, so you could feel when it's a kind of right. But you can measure it should be around 11 millimeters. And once I'm started, there's a little bit of friction between the plastic and the screw. And then I take the second screw, and now I'm pushing it in with my thumb here while tightening. And I could feel when it starts on that nut. So it's going to push the nut up a little tiny bit, so they're never really too snug in there. But it can't fall out either. It's trapped now. And then I could just take this one here and tighten it all the way down now. And for actual like production assembly, we could probably come up with some sort of spacers or jigs to hold all this, and again, use of power screwdrivers. This is just a hair too long for the 2-inch. And this is the 2.5-inch screw currently. But again, in your design, this is going to be the one side and the other side of the rectangle in the bottom, let's say, right? And hopefully we can put these, something like this in the walls, at least screw a nut in some fashion. And it could be a little more than just 2 holes, but because all of the rotation is going to happen on these nuts here.